We're going to start this class by reviewing for factoring. So we're going to talk about 3 different types of factoring. We're going to talk about the greatest common factor first. Then we'll talk about factoring trinomials, and then we'll talk about solving by factoring. So what a greatest common factor is, or a GCF, this is the largest number and or variable two or more terms have in common. Okay, so again, the largest number and or variable that 2 or more terms have in common. So if we're looking at the example I gave you here, which is 5x cubed minus 10x squared plus 15x, you can tell that everything is divisible by 5. And so that would be our number they have in common. And you can also see that each one has at least one x. So they have an x in common. Now, what we want to do is we want to state not only what the greatest common factor is, but what you would have left over if that was taken out or divided out. Okay? So if you think about this, if you divide 5 divided by 5, you would have 1, which we don't like to write ones down unless there's no variable. But we have x cubed divided by x, which would give us x squared. Minus. Do the same thing with the second term. You do 10 divided by 5 would give you 2. You have x squared, but you're dividing out one of them, so that means you would only have one left. Plus 15 divided by 5 would give you 3. Since you're taking away that x or dividing out that x, you wouldn't have anyone because you just have 1 and you're taking that away. And that would be your answer as far as factoring the greatest common factor. And we'll have some more examples. So for our first example of greatest common factor, we've got 6x squared y plus 10x minus 2y. Again, we're going to look for the biggest number that will divide into all 3, and we're going to look at the variables as well. So if we look at 6, 10, and 2, those numbers, you'll notice that the biggest thing that will divide into all 3 is a 2. So let's write that down. Now let's look at the variables. The first term has both an x and a y. The second term only has an x, and the third term only has a y. So if we're looking to see if the variable's in common, remember they have to be in common with all 3. So even though the first 2 have an x in common, because the last one doesn't, x's aren't in common. The first and the third one both have a y, but because that middle one doesn't, y's are not in common. So the greatest common factor for this is just a 2. Now let's see what we have left over. So we're going to do 6 divided by 2, which would give us 3. And remember, we're not messing with our variables since there was nothing in common. So that gives us 3x squared. Plus 10 divided by 2 is 5x. And 2 divided by 2 would be 1. We don't want to write that down because we still have our y, so we're just going to put a y there. Okay, and there is our first example. And remember that if you're ever wondering whether or not you got your answer correct, you can always take what your answer is and distribute it and see if you get the same as your question. So if we took this and we distributed out the 2 for each one of these terms, we would get 6x squared y plus 10x minus 2y, and that should match our original problem. Okay, so you can always check your answer with multiplication. That's one of the really cool things about it. So for our next example, we have 5x squared y plus 3xy cubed plus 21xy. And again, we want to look at our numbers first. We've got 5, 3, and 21. And again, remember, for something to be in common, they do have to be in common with all 3. And I know that 3 is in common with 3 and 21, but 3 does not divide 5 evenly. So there is nothing in common as far as numbers go. Now, if we look at the variables of these problems, notice that all 3 of them have at least one x and one y. Okay, and when you're looking at variables, you're always going to look at the smallest or the smallest exponent, or whoever has the fewest, because that's what they have in common. So in this case, they have x and y, just one of each. Okay, that means we're going to take an x and a y from each term. Okay, so we still have our 5, and if we're taking away one x and it has 2 from that first term, that means we just have 1 left, but our y would be gone. Plus, same thing here, we're going to keep our 3. If we're taking away one x, that x is gone, but notice we have 3 y's, so when we take away one y, we still have 2 left over. And on this last one, we've got our 21. We're not messing with our number. And notice we would take away both x and y, leaving no variables on that. And again, if we wanted to check our answer, we could distribute x, y, and see if we got back to our original. For our third example, we've got 6x squared y minus 10y squared. And again, look at the numbers. We've got 6 and 10. So the greatest common factor, the biggest number that will divide into both 6 and 10 is 2. So let's write that down. And then we look at our variables. We've got x squared, y, and then the other one has just y squared. Okay, so they don't have an x in common because our second term doesn't have any x's, but they do have a y. And remember, we're looking for the smallest, and so that would be that first term that has just one y. Now do your parentheses, and we're going to start dividing and saying what's left over. So we've got 6 divided by 2 is 3. We didn't mess with our x's at all because they weren't in common, but we did take away that one y, so that y is gone. Minus 10 divided by 2 is 5. We have 2 y's in that second term, and we're only taking away 1, so that leaves 1 left over. So our answer would be 2y times 3x squared minus 5y. So for our last example of the greatest common factor, we have 3x squared minus 9x. Again, just looking at the numbers, 3 and 9, the greatest common factor for that would be 3. Since they both have one x at least, then we're going to have that x. And now if we look at this, if we take 3x and we divide it into 3x squared, we would have just an x left over. Minus 9 divided by 3 would give us 3, and since we're not going to take away that x, we would have any x's left over. So our final answer would be 3x times x minus 3.